Welcome from Vegas, everyone. So recently I took a class about software-defined radio through Mike Osmond, and Michael is the one who helped create the Hack RF1 from Great Scott Gadgets. That is an open source software-defined radio. So I've had one for a while, didn't know that much about it. Basically, the class was more about complex numbers and how radios actually work than the Hack RF1 or how to deal with that. My recommendation for them was to create a secondary class, a follow-up of, okay, now that you've figured out the basics of how to play with the Hack RF1, how do you utilize it? Though we did learn a few things. And so one of the things we learned was the basics of how to identify a particular device and be able to reverse engineer how the RF works within it. So I'm going to walk through that real quick of what we discussed. So for this demonstration, I wanted to be able to show my lab setup here in my hotel room in Las Vegas, Nevada. Yes, that is all we're playing with. So as it turns out, in my hotel room here in Vegas, there is wireless phones in the room, which seemed kind of weird. I'm not used to wireless phones, and I mean wireless like old school wireless phones like I remember from the 90s. So I took a look at it, and I took a picture of the bottom of it. Now, this didn't have the FCC information that Mike mentioned whenever doing this kind of process, but it did have a little bit of information up here that was called Intertac 3177099. That seemed like a good thing to look up. It's got a couple of listings. We know that the phone is by VTech, so we have a bit of information, but not a lot. But I thought maybe if we searched for that Intertech number, then we might find something. And so whenever I Googled for it, I started looking at the results, and one of them was a results from fccid.io, and it talked about a 1.9 gigahertz hotel cordless phone. As I mentioned, I'm staying in a hotel, so this was relevant. So I took a look at the link, and we see, hey, look, there's that Intertac 3177099. There's pictures of it here. So at the top of the page, we can see that it has FCC ID, VTech Communications, 80-H 025-00, label, artwork, and location. So I'm going to go back one to the 800, and what we have is a lot of information about exhibits relating to this particular phone. Now, if I wanted to know more details, I could click around through these and find lots of information, but really all I care about right now is the frequency range. And the frequency range for both the application 1.1 and 2.1, which happened in, at least originally from 2010, was in the 1.92 gigahertz range. So what we did was we plugged in our Hack RF1. I installed Xquartz and all of the different software related to Hacker RF and GNU Radio. And so now I have an app called GNU Radio Companion. So I started up GNU Radio Companion, which works as a Python application, and I'm able to write basic concepts of how to handle the data coming from the Hack RF1 without actually knowing how to code. Though I personally know how to code, this makes it very, very easy. So this is a new project that I created specifically for this. I started off with leaving the sample rate at 32,000, which is the default. I'm using the WX GUI as we talked about in class because it was a little bit nicer and a little bit easier. What we don't see over here is if I look for a different module of things I can add. There's lots of options. I created a slider called frequency. and that slider, basically I started off at the 1.921536 gigahertz. I said the minimum was a gigahertz under that, and the maximum was a gigahertz above it. I put the number of steps as 200 and left everything else the same. So that added me a slider to this particular instance. I specified the source as the hack RF1. I basically left most things the same, except for I changed the frequency to frequency. I changed the bandwidth to do at 4 megabits per second for the bandwidth. I turned the RF gain down and the IF gain and BB gain up. I think that was all I changed on that one. I then added a throttle, which limited our sample rate to 32K, so we didn't overload the system. I then set up a FTT sync GUI where I set the base bandwidth frequency to that frequency slider. The sample rate is the same. Most of this I didn't make many changes on. I did turn on peak, hold, and peak and average because I like the way it looks, and I would turn them on anyway. And then along with that, I added a phosphor sync, which basically is just another graphical representation of the information. And all I really changed was the frequency and sample rate to make sure that they were set to the variables that we created. So with these things set, I was able to run the application, which was generated for me through the GNU Radio Companion, which connected to our hack RF1. As you can see on the top, what we have is a little bit of information. You can see down here on the bottom, it's pretty simple and straightforward. If I come up here, I can change the frequency. We're already seeing some peaks. It's pretty wide band. The reason we can see so many changes here is because we are in a hotel where there's a lot of people using this particular phone. But so if I turn on my phone, you can see that there's a very wide band peak in there. Then whenever I turn it off, the peak slowly falls back down to normal. But again, we're in a busy hotel. We're in the middle of Vegas, so it makes sense that we would continue to see things. But as you saw, whenever I turned it on, we definitely saw it. So I could record that. I could add a file sync and be able to write all the information to a file and then continue digging from there. But this, I just wanted to show that basically we showed how we could easily reverse engineer a RF frequency based on the FCC information that we were able to find online that was registered. So we were able to pinpoint exactly where it was. From there, if it was something unique, we could record the radio signal, replay it, or potentially decode it to try to figure out what it's saying, to try to be able to spoof it, just depending on the modulation and the type of data that was being passed across. Basically, for those who are coming from the network world, think of it as a network that has no predefined formats, and that every company that uses it uses a unique format. It's very interesting reading documentation and finding out how little you actually know about radio frequency and how complex it is. But the class through Mike Osmond actually taught me a lot more about complex numbers than I ever knew before, and a lot more about how radio worked than I ever realized. So it's a really cool class. I hope to make further videos about how to use the tools that he pointed out to us and things such as that. He also has a video series you should highly recommend looking at. And yeah, so good night from Vegas.